Okay, in this video we are having a look at question 11 from the WJC Additional Maths paper from June 2014. So let's have a look at what we've got. We've got a trapezium here, and we are told that the area of the trapezium is 28 centimetres squared. We've got a rectangle of length x plus y centimetres and width y centimetres has an area of 43 centimetres squared. Show that xy equals 28 minus 2y and xy equals 43 minus y squared. Okay, we got the diagram there of the trapezium. Let's draw the diagram of the rectangle. So we have that. So we have a length of x plus y and a width of y and an area of 43. Okay, so let's have a think about what we need to show. So we have two shapes and we have two equations that we need to work out, and both of them involve the area of the specific shapes. So let's have a look at the area of the trapezium to start off with. So the area of a trapezium is half of a plus b, so the two parallel sides, multiplied by the distance in between them. So let's look at that in terms of what we've got. So the trapezium, we have the area is 28. So 28 equals 1/2 of a plus b. So a and b are your parallel sides. So this is your a and b. So if I add those together, I get x plus 4. So that's 2x plus 4. And I multiply that by h, which is the distance between the parallel sides. So it's actually this length, y. So multiply that by y. Okay, so 28 equals, well, if I halve that bracket, half of 2x plus 4 is x plus 2. So I get x plus 2, still multiplied by the y. So I get 28 equals xy plus 2y, which is similar to this. So let's make xy the subject like it is there. So if I make xy the subject, I need to take 2y off both sides. So I get 28 minus 2y equals xy, which is what we want. It's just on the opposite side of the equation, so that's fine. So let's have a look at the rectangle. And we know that the area of the rectangle is 43. And the area of a rectangle is base times height. So it'll be y multiplied by x plus y. So expanding the brackets, xy plus y squared. And let's have a look at what we need to get to. We want xy to be the subject here, so I need to take y squared off both sides. So I get 43 minus the y squared is equal to this xy. Okay, part B. Hence, write down a quadratic equation in terms of y. So when it says in terms of y, that means I don't want any x's involved in there at all. To calculate the lengths of the parallel sides of the trapezium, you must use an algebraic method, not a trial and improvement method. So the lengths of the parallel sides of the trapezium, which is x and x plus 4. Okay, so let's have a think about what we can do. Looking at the question, because it says hence, we need to be using the answer to part A. So the answers to part A with these, 28, or let's write it in the way they wrote it in the question, xy equals 28 minus 2y, and xy equals 43 minus y squared. So what we have is two expressions that both equal xy, and they're both the same xy, which means that these two expressions, now the 28 minus 2y and the 43 minus y squared, they both equal the same thing, so they must both be equal to each other. So I can say that we can have 28 minus 2y equals 43 minus y squared. So we end up with a quadratic here now in terms of y. But if I wanted to try and solve this, I want the quadratic equal to 0. So I'm going to add y squared to both sides. I've got minus 2y. And then I'm going to take 43 off both sides. So the 28 minus 43 is negative 15. And this is now an equation that we can solve. So this is relatively simple to factorize this one. It would be y minus 5, y plus 3. In which case, if those two multiply to give 0, then that means that either y minus 5 is 0. So you'd have 0 multiplied by something, which would always give me 0. Or the second bracket, y plus 3, is 0. Because then we'd have something multiplied by 0, which again would be 0. So solving both of those equations, I get y equals 5 and y equals negative 3. Okay, now what we need to try and find is the lengths of the parallel sides of the trapezium. So we need to work out what x is and what x plus 4 is. So we need to work out what x is, essentially. Now, if we're looking at the value of y, one possible value of y is 5, one possible value of y is negative 3. If we look at the diagram, y is this height. Now, because we know it's a length in a shape, immediately we should be able to rule this one out, because that's impossible. You cannot have a negative length. So this one is impossible. So therefore, my y is going to be equal to 5. So this has to be the correct one. So now I have two expressions here that involve x and y. If I make a substitution in for my value of y, I should be able to find my value of x. So I'm going to substitute y equals 5 into this expression here. So I'm going to say using y equals 5 and xy equals 28 minus 2y, I can get 5x equals 28 minus 2 5s. So that's 5x equals 18. So my x will be 18 over 5, which is 3.6. And this is now in centimeters. So therefore, the parallel sides of the trapezium are x, which is 3.6 centimeters, and the other one was x plus 4. Well, if you know x is 3.6, then x plus 4 is going to be 7.6 centimeters. And that's our solution.